Welcome back to the shop and to the channel. Got a little bit of an interesting project today. I've noticed a lot of my favorite YouTubers have been building and working on different kinds of steam engines lately. Blondie Hacks has built several steam engines, and Joe Pye just finished one up, and I just saw a video recently from Mr. Pete. And it all looked like a lot of fun and some good challenges, so I figured I'm going to go ahead and give it a try myself. But none of this stuff has anything to do with it. Now this is a steam engine. More precisely, it's a 280 steam locomotive built in 1945 for the Reading Railroad, number 2100, that is currently under restoration by American Steam Railroad here in Cleveland, Ohio. If you've watched Blondie Hack's video on her steam locomotive that she's building, she talks a little bit about stay bolts, and all of these things here that you're seeing on the side of this locomotive are the stay bolts. Their function generally is to maintain the structural stability of the boiler and the firebox, which is on the other side of this. Now all of these stay bolts come through the main shell and protrude through these sleeves, and that rounded end is the end of the stay bolt. And on most of these stay bolts you will see that hexagonal cap that's screwed on top of it. Now that's screwed on in order to provide a watertight seal between the sleeve and the stay bolt. However, on I think it's well over 24 of these stay bolt sleeves, there's some nicks and gouges in the face of it, which is not allowing for a good seal. So what I need to do is build some kind of a device or a tool that we can use to lap the surface of that sleeve in order to provide a better watertight seal for when the cap goes on. So the idea I have for solving this problem is to build a lap for that surface. But I want to make sure that the lap is perpendicular to the direction of the sleeve, and so for that end I need to make a guide that will thread on to those stay bolt sleeves. Well, since my pickup truck is just a little bit too small to put that steam engine in it and bring it home so I can check the thread, I need to build a facsimile of that stay bolt sleeve thread. It is 1 3/4 12 TPI. So I've got some material chucked up in the lathe. We'll turn this down and single point thread it. Well, I did bring home one of the old stay bolt caps, so I can use that to make sure that I'm making the right kind of progress. Well, I've got another piece of scrap here, cut off piece of 4140 that will chuck up in the lathe, and this will eventually become the guide. Well, this was partially turned down and bandsaw cut, so I'm going to go ahead and face this off and make it look nice before we bore most of it out. I have a center drill in the tailstock that I'm just going to use to spot drill, and then I will drill out the center of this to the minor diameter of that 1 3/4 inch thread, which is 1 inch 665 thousandths. Next, I will put a nice, generous pilot hole through the center of this piece. I want to make this bore larger before I bring in the boring bar, so I have a 1 inch reduced shank drill in the tailstock, and I've got the lathe in back here. I have a carbide insert boring bar in the tool holder, so we can start boring this open to that 1 inch 665 thousandths minor diameter for the thread. Well, that other boring bar was a bit too thin for as much stick out, and I was getting a lot of chatter. So I've switched over here to a brazed on carbide boring bar. It's got a thicker shaft on it, 3/4 inch, so I think it's still chattering a little bit, but it's less than what the other one was doing. I have a little makeshift shield here stuck up in front of the chuck because this thing is throwing hot, stringy chips all right into my face. So this seems to happen quite a bit whenever I'm boring larger pieces like this, as the chips come out the other side of the piece. They have a tendency to fling right at you, and this helps at least a little bit. I checked the diameter here. My target for the minor diameter of those threads is 1 inch 665 thousandths, but I'm going to leave it a little bit short of that. When I turn this part around to finish off the other end, I will finish this bore to that dimension before single point threading the internal threads. The lapping tool that will get inserted into this guide will be about 1 7/8 inch in diameter. So I want to enlarge this bore to that diameter, but I only want it to be about 3/4 of the depth of this guide. The rest of it will be for the threads. I have a dial indicator on my bedway here so I can stop the travel of the carriage when I've reached the depth, and it'd be a little easier for me to watch a zero here since I don't have a DRO. Since this bore is not the entire length of the part, I can use that smaller boring bar now, and it should give me a much better internal surface finish. $76.50. That's good. Well, I need to turn down the opposite end, so I flipped it, but I've also put it in my 4-jaw chuck and dialed it in to be concentric. So I'm going to face it to length, turn it down to the same diameter as the rest of the part. This end of the part is where the thread will be machined. I left the diameter a little short of the minor diameter for the 1 3/4 12 thread pitch. So I'm just got the boring bar in here to finish off this last section of the bore to that 1 inch 665 thousandths minor diameter.
668. That's good.
Well, we got the lathe set up for threading 12 threads per inch. So we'll put a little blue dicum on the inside of this bore here so we can take a scratch pass. A quick check with a thread pitch gauge shows that I'm right on 12 threads per inch, so that's good. We can move on with the threading operation. Well, according to the math, the thread height here should be 52 thousandths of an inch, so I have a dial indicator set up on the back of the tool post, and we'll move the compound out a few thousandths at a time until we reach that target. Well, we're about 50 thousandths depth of the thread here, so I'm going to check it here with our homemade thread gauge and see how close we are. Well, that fits pretty nice. I do hope that we are right on with this because I really don't want to have to chase these threads again if it doesn't fit on one of those stay bolt sleeves. Well, I'm not completely finished with that guide. There's some milling that I want to do on it, but I'll do that later. In the meantime, I've got another piece of material here that I'm chucking up in the lathe that will end up becoming the lapping tool itself. Well, I've got some material to remove off of this, so I'd like it to run a little bit truer than it is. So I've seen a trick, and it's worked for me, where just using a rubber mallet or plastic hammer will kind of knock it into some level of concentricity that's better than if I would have left it alone. I'll start by machining the diameter down to about 1 7/8 of an inch. I want this to be a nice, comfortable sliding fit in that guide, so we'll probably go just a hair smaller than that, maybe a couple of thousandths. Well, that's exactly the kind of fit that I want. So the next step will be to bore out the end of this tool to make clearance for the domed part of the stay bolt. Well, I'll start boring this out, this recess with a couple of drills before moving on to the boring bar. This only needs to be maybe an inch deep. I've gone as far as I can with drills, so now I've got the boring bar in here, and I just need to bore out this diameter until it just clears the stay bolt dome. That gives me the best opportunity to get as much purchase on the face of that stay bolt sleeve so it can be properly lapped. Well, we'll clean up this face of the tool now that our bore is to depth, and we'll go ahead and put a chamfer on the inside and outside edges. Well, now that this has had a chance to cool down, I want to check that bore again because visually looking at it, it still looks like it's too small.
Okay, now this isn't making any sense. Okay, I still have ways to go.
Well, I'm glad I double checked that because I still have quite a little bit to hog out of the center of this.
Okay, 1,000 over. I can deal with that.
Well, that's much better. I just need to redo that inside chamfer. Well, I have the carriage locked in place in the lathe and back gear so we can cut this off to length. This is not a critical dimension, so I just used a scale to get to the rough end. We'll just keep a constant supply of oil here as I engage the cross feed power feed to start the cutoff. Well, before we get too far cutting this off, I do want to chamfer this end, and then we'll go ahead and complete the cutoff. I don't normally use power feed to part off stock in the lathe, as I find that my success rate has been pretty dismal in the past, but I've gained enough experience understanding the material that I'm using a little bit better that I feel a little more confident now in giving it a try. Of course, I've got my hand on the clutch knob so I can disable it, turn it off at a moment. Of course, it'll probably be too late, but at least I'll be able to stop it. I was getting some chip buildup between the tool holder and the stock, so I did have to periodically disable or turn off the power feed and back the tool out in order to clear those chips. Well, we'll take out the remnant and put our piece back into the chuck so we can go ahead and face off the end of it and make it look a little bit nicer. I want to give the user of this tool, whoever that might be, the option of spinning the lap with a wrench or maybe even a drill driver. So I have a piece of hex stock here that I'm going to turn the end of it down a bit to match the diameter of the through hole that we just drilled in that lap. In the meantime, we'll go ahead and cut this off to length, and then we'll flip it around, face it, and put a nice chamfer on the end. We're over here at the Bridgeport to do the final machining on the guide. I've got it chucked up in the rotary table, and what I plan to do is put some wrench flats on the end of this just in case it gets stuck on one of those stay bolt sleeves. We'll be able to take a wrench to remove it. And the last machining operation I want to do on the lap itself is to cut some grooves in the face of it as sort of a swarf trap, just to give that swarf that comes off of the end of the stay bolt sleeve a place to go. I have my smallest end mill in the spindle here, and I've got the RPMs up to almost 3,000 RPM, and we got the feed down to about 2 inches a minute, and my depth of cut is around 20 thousandths. I'm using the air gun here just to blow away any chips to help with eliminating any chip buildup. I really don't want to break this end mill. I want to make it a little bit deeper, so I'm going to go down another 20 thousandths and come right back. I took that piece of hex stock back over to the lathe and ran a knurling tool on it. That should give me enough expansion of the diameter of that shaft that it should fit in there pretty tightly. I'm going to put some Loctite on it anyway, just to be sure. Well, I got to go handheld here with my cell phone because I am up on a ladder, but I had to make a modification to this guide. I ended up having to cut away most of the threads. That surface finish is hideous, and shorten it a bit in order for it to fit over top of the stay-bolt sleeve. But it does thread on it pretty nicely, and once it's seated all the way, there's enough of that face exposed that the lap tool should be able to take, just a few thousandths off, enough to give us a good seal. We got Gordon here from the ASR group, and he is getting ready to put this tool to its first test.
Right here's a little flat spot we're trying to take out, and a little rough spot over here we're trying to take out. We'll start by filling this gap with a grease compound, kind of seal off the possibility of the lapping compound getting down in there too heavily. Take off the excess. Put our guide sleeve on. And I'm going to make sure that guide sleeve is in far enough that the section we're trying to lap is above the thread section. Then we put some fresh lapping compound on our cutter blade. And since we don't have to do a whole lot here, I'm doing this by hand. I don't want to get too aggressive. And I can feel an abrasive action taking place here through the tool. You use a back and forth motion and then rotate it a little bit to change the cut position. And we'll, just out of curiosity, we'll take this out and we'll take a look. I don't think we did much change here, but we'll see if we're making some progress. You can see this one's almost gone.
So just that little bit of lapping, you're seeing
this roughness here is still here. We'll still have to go some more, but it's probably 50% of it's gone. These were caps that when we put the gasket in and put the caps on, there was enough pressure just to seep and it would drip. It wouldn't spurt out, but there was enough of a gap between the seat and the gasket to allow a small leakage.
How much pressure did you put in?
320 some pounds.
What's the operating pressure of the boiler?
245.
So you were well above the operating pressure.
Yes, I believe the number's 20%. Okay, you can see that mark can no longer be felt with your fingernail. That one's still going to need just a little bit more work, but it's almost gone.
Cool. I'm glad it's working out.
So it'll take some work. We could put a driver on this nut and spin it a little bit more, but we don't want to be too aggressive. Because if you do any damage to this, it's a major project to have to cut it out, re-drill the holes, got to ream the holes to fit the sleeve, weld a new sleeve on, then ream it out, and put it all back together and weld the inside bolt again. So it's a major project to get this.
So slow and steady wins the race.
Absolutely.
Well, if you like this video, go ahead and give it a thumbs up. If you're not a subscriber, I'd appreciate you hitting that subscribe button. I enjoyed making this for ASR, and I hope it comes in handy. Thanks for watching. We'll see you on the next one.